This unit requires us to apply vectors to problems in the real world. So in this case, we often consider the combined effect when vectors are added together. So adding a vector together sort of makes it into a resultant vector. So for example, if I have a situation like in still water, maybe a person, Jason, can swim at 1.5 meters per second. So let's say there is a river here, and maybe Jason is at a point A, planning to swim to point B. So in still water means that when there's no current or nothing running along the water, Jason can swim at 1.5. So if there is a current, if there's a current flowing at 0.5 meters per second to the right of the river, okay? So if Jason starts diving straight from A towards B and swim without allowing for the current, what will the actual speed and direction be? So in a situation like this, so Jason is intending to swim from A to B. However, there is a current that's going to the right here. So it sort of makes the resultant vector become slightly slanted to the right side, like this. So the question is, what will the actual speed and direction be? We know that in still water, Jason can swim at 1.5 and the current is 0.5. So this means that this has a magnitude of 1.5 and 0.5. So what is the actual speed of Jason? We need to use the Pythagoras Theorem. So we know that to get the length, let's say length x, we know that x squared equals to 0.5 squared plus 1.5 squared. So to solve this, we can use 0.5 squared plus 1.5 squared to get the answer 2.5, which is x squared. To get just x, we have to square root 2.5, which is the answer. And therefore, we got 1.58 as the new speed. So the other question is, what will the direction be? In order to get the direction, we sort of need to consider this angle here. So in order to consider this angle, we have to use trigonometry because it involves right angle triangle. So considering trigonometry, for example, if I use tangent, so this could be an angle theta. Tangent theta is equivalent to opposite over adjacent. So opposite over adjacent, 1.5. We will find that the angle will be, in order to get the angle here, we sort of need to shift the tangent over here. So it becomes shift tangent, 0.5 over 1.5. Putting this into the calculator, we will get 0.5 over 1.5 equals 18.4 degrees. 18.4 degrees. If you don't get 18.4, do not panic. It means that maybe your calculator setting is not set to degrees. So in order to set your calculator setting to degrees, you have to, this is a Casio calculator I'm using. So you can go shift set up, scroll all the way down to angle and switch it from radian to degrees. So you would have gotten this answer. So it means that initially when we are learning vectors, we need to consider two things, which is the magnitude. So we have the magnitude here, which is the speed, and also the direction. So the direction that we have is 18.4, meaning that Jason is actually going at 1.5 meters per second to the right. So 18.4 degrees to the right of the intended direction. So if Jason wants to go from A to B, and now we have to consider the current. So at what angle should Jason aim to swim in order for him to reach A? So we know that again there is a current flowing at 0.5, and we know that just now when Jason was aiming straight to B, the actual resultant is actually here. So it means that in order for him to reach straight to B, he should be aiming slightly to the left. So if Jason starts aiming slightly to the left, for example, to the left here, and adding this up with the current that's going to the right, we sort of get a resultant vector from A to B. So at what angle should Jason aim? So now we know that this is the swimming in still water, and therefore this is 1.5. That's the current, which is still 0.5. So in order for us to consider the angle, the direction, maybe we can consider the angle right here. So the angle here, maybe let's say we call this angle of phi. So in order to calculate the angle phi, we still need to use the right angle triangle, which is using trigonometry. So we have opposite and hypotenuse. We can use sine phi equals to opposite over hypotenuse. In order to calculate the phi, we can shift sine 0.5 over 1.5, which will give us shift sine bracket 0.5 over 1.5 will give us 19.47. So Jason should aim to swim 19.47 degree to the left in order to get straight to B. And the other question is, what will the new speed be? In order to consider the new speed will be this line over here. So the new speed will be just 1.5, which is the hypotenuse square, equal to 0.5 square plus, this is the one we need to find, so let's say we call this as y square. So in order to solve y square, I need to have 1.5 square, take 0.5 square equal to y square, 0.5 square, take 0.5 square. So I know that my y square is 2, and therefore my y will be square root 2, which is 1.41. So it means that in this condition, Jason's actual speed will be 1.41 meters per second, and the direction will be 19.47 degrees to the left.